Now, before I go to this iodoform test, let me tell you a little bit more about what you can say some commercial forms of ethyl alcohol. There is just now I was saying, absolute alcohol, which is hygroscopic in nature. So, first one will come to the rectified spirit. Children, you write it down what I am saying you, write it down. What is rectified spirit? A mixture containing 95% alcohol and 5% water is known as rectified spirit. A mixture containing 95% alcohol and 5% water. Next is absolute alcohol. It is about 100% alcohol. It can be obtained by distilling the rectified spirit, the one which I told you just now to you. Rectified spirit over quicklime. What it will be heating it over quicklime. Okay. The last traces of water are removed by distilling the lime alcohol over a calculated quantity of sodium or calcium. The first while we heating with quicklime, because quicklime is what? Dehydrating agent. It absorbs moisture. Again after that we'll be heating it over, what is that? Calculated amount of sodium or calcium. Again to remove the last drop of water which is being present there. Got it? So hence what we get it here? If water is being removed from alcohol, then what we get it? We got only alcohol. So 100% alcohol. So it is absolute alcohol. In the name itself it says. Now next is methylated spirit or denatured alcohol. You know it, this one. Once again let me tell you a little bit. Listen carefully. Now, what I said, methylated denatured alcohol. Actually, see, alcohol used for making beverages, means for drinking purposes. Now, it's what you can say, which one is drinking purposes alcohol is used? Ethyl alcohol. Alright. Now, that is also it is being used in industries, you must be knowing it. So, generally what the government is doing is that to discourage this particular purpose, what the government is doing, it is mixing the methyl alcohol with ethyl alcohol knowingly, so as to decrease the consumption of use as a liquor, because actually it is used as an industrial solvent, ethyl alcohol. Clear? So make it unfit for drinking purposes. The industrial alcohol is mixed with poisonous substances like methanol, pyridine, etc. The process is known as denaturing and the product is called denatured alcohol. Alright, what I said, it is being mixed with pyridine, methyl alcohol, and this is called as denaturing, so as to prevent consumption of ethyl alcohol. Alright, now the ethyl alcohol mixed with methyl alcohol is known as what? Methylated spirit, or it is called as denatured alcohol. Next is power alcohol. Last one, mixture of petrol, alcohol and benzene used for power generation is called power alcohol. Methyl alcohol, then what you can say, benzene and petrol, it is said to be as power alcohol. It can be ethyl alcohol also. If not methyl, we can use that ethyl alcohol also. Basically, you have to take alcohol, petrol and benzene mixture, and this mixture is used for power generation, and this is called as power alcohol. So we got it rectified spirit, then we got absolute alcohol, then we got denatured alcohol, and then the last we got the power alcohols. Now we will come to, that is the test. There is what I said, iodoform test. Now, very important this iodoform test. Very important. Now, iodoform test is being given by alcohols. Which alcohols? Note it down, children. Note it down. Alcohols which contains CH3CHOH group. Alcohol which contains CH3CHOH group. Whichever alcohol which contains CH3CHOH group, this will give iodoform test. This is the basic conditions for iodoform test. Got it? In alcohol chapter you will be studying. You are studying now. Got it? You will be reading iodoform test in ketones also, in aldehydes also. There the condition is going to change. But here the basic condition is that any that is alcohol which contains CH3CHOH group. Now you must be wondering which one. Ethyl alcohol, CH3CH2H, it contains CH3CHOH group. Then propan-2-ol, isopropyl alcohol, CH3CHOH CH3. Isopropyl alcohol, not propanol. Propanol is CH3CH2CH2OH. It does not contain CH3CHOH group. Got it? So isopropanol. Then isobutanol, we can say that, or butan-2-ol, whichever you can say, or propan-2-ol. Clear? So they give what you can say the iodoform test. Methanol will not give. It does not contain CH3CHOH group. Then propanol will not give. Butanol will not give. Understood now? So which they give, what is the condition, or which alcohol gives this particular test? That is first of all CH3CHOH group. Now what we do it in it? You can see the reaction there. I have taken there ethyl alcohol with iodine and sodium hydroxide. I am heating it. What I am getting it? I am getting iodoform and HCONA, NaI and water. I am getting it. I have discussed with you in the halides chapter also. Haloform reaction. I have told you. Alright, in the halides chapter I have discussed. Same thing here also. It is written in one sentence. There I have given you in 3 to 4 steps. So you get iodoform. The iodoform is what? It's a yellow PPT. Yellow PPT, which is having a characteristic smell. Alright, which is having CHI3, it is having characteristic smell, that is called iodoform. Similarly, propan-2-ol, again same thing, heat with I2 and NaOH. You will be getting iodoform as you can see it, along with CH3CONA plus NaI plus water. Alright, same thing, it is having a characteristic smell, it's a yellow PPT. Alright, so you can carry it out this reaction with Na2CO3 also. Instead of NaOH, you can also take aqueous Na2CO3 solution, you can take it. Got it? And you have to heat it at temperature of 333 to 343 Kelvin, then you will be getting it. So because aqueous Na2CO3 is nothing but known as NaOH, isn't it? Na2CO3 upon hydrolysis. Aqueous means what? Hydrolysis. Na2CO3 plus water will give you what? NaOH plus H2CO3. So you are getting it there also. So that also you can take it. So the basic thing is that alcohol which contains CH3CHOH group is giving the iodoform test. What is iodoform? CHI3, it's a yellow PPT which is having characteristic smell. It is given by only these compounds like ethanol, propan-2-ol, butan-2-ol in this way. Methanol does not give, propanol does not give, butanol does not give. So hence this particular test is also used to distinguish between the different types of alcohol. We have seen the Lucas test, Victor May's test, which distinguishes 1 degree, 2 degree and 3 degree alcohol. This is used to distinguish the, what you can say, the different types of alcohol, we can say that. I hope it's understood. So this is about your alcohol chapter. The next is phenols. Now in the phenols, before starting, you can see the nomenclature, you go through your book, the nomenclature. Alright, nomenclature, you go through your book. One day I will do a test upon nomenclature, understood? Just to check it whether you are studying or not. Okay, so in the beginning of the chapter, you are having the nomenclature of phenols, like you will be getting resorcinol, that is meta dihydroxybenzene. You will be having quinol, where the OH group is attached in first and fourth position, para dihydroxybenzene. Alright, you will be having catechol, where the first and second position, that is ortho position, you will be having 2 OH group, orthodihydroxybenzene. In this way, you will be having pyragalol, hydroxyquinol, fluoroglucanol, in this way. Please go through it, all these things. Alright, it's there in your book. You will be having cresol, so many. Now, straight away, we'll go to the preparations, as you can see it on the screen. So, that is nothing but from sulfonic acid. So, I have taken here benzene, that is sulfonate, sodium benzene sulfonate. But before going to it, just let me tell you a little bit about phenol. Now phenol was first isolated by Runge in 1834, got it, from coal tar, and he named it as carbolic acid. Why he called carbolic acid? Because he got it from carbon, that is coal, and oleum, that is oil. Alright, hence it is known as carbolic acid, this particular one. Now also phenol in the market is named as carbolic acid, phenol. If you go and say phenol, you will not be getting it. But if you will say carbolic acid, you will be getting it. What is the formula? C6H5OH. Alright? Okay, let me say you the reaction. So when sodium benzene sulfonate reacts with sodium hydroxide in presence of 573 to 623 Kelvin, you will be getting sodium phenoxide, which upon acidification with HCl aqueous, when it reacts, it gives you phenol plus NaCl, and Na2CO3 and water is being released. We can say that. Similarly, if you take benzene diazonium chloride, you can see the reaction. You have to write it down, these reactions, in your notebook. Then only you will come to know. Simply you don't study it from this mobile. Understood? Benzene diazonium chloride plus water, when it reacts with dilute sulfuric acid and heat it, what you are getting? You are getting phenol plus HCl plus nitrogen. You will be getting it. Clear? In this way. Now benzene diazonium chloride, how you will get it? I have already discussed with you. Once again, let me tell you. This is known as what? Diazotization. That is when aniline, listen carefully, those who have forgotten, I mean aniline, benzene ring NH2 plus NaNO2 plus HCl at 273 to 278 Kelvin. This is very important. It gives you what? Benzene diazonium chloride, benzene ring N2 plus Cl minus plus water. Alright, plus NaCl you will be getting it. So in this way you will be getting, that is benzene diazonium chloride. Again I say aniline plus NaNO2 plus HCl. That is to balance it you have to take 2 HCl. In presence of 273 to 278 Kelvin will give you benzene diazonium chloride plus water plus NaCl. You will be getting it. Okay. You will be getting it. So, but this method is extensively used for the preparation of phenols from corresponding hydrocarbons. Okay, this method is being extensively used. What? Which method? That is benzene diazonium chloride. Now, based upon this, I am giving you a homework. You have to what you can say, write down, that is two reactions. One is how will you prepare, that is phenol from aniline one I said. Now next I am saying you from nitrobenzene, and another one I am saying you from benzene. Understood my question? Aniline, just I have said you, aniline to benzene diazonium chloride, benzene diazonium chloride to phenol, you got it. Now my question is from nitrobenzene how will you prepare phenol, and the next question is from benzene how will you prepare phenol. You have to write it and you have to show it to me, that from how did you get it, this one. Okay, now one more question I am giving you. This is your board question. It has come in the previous years, this particular one, that I am giving you para-nitrobenzene diazonium chloride. Okay, now don't worry, what is para-nitro? Only benzene diazonium chloride, at para position you will write the NO2 group, that's it. Para-nitrobenzene diazonium chloride, how will you, by using this, how will you prepare para-nitrophenol? Very simple it is, if you apply your common sense. It is para-nitrophenol. How will you prepare? From para-nitrobenzene diazonium chloride. So altogether 3 questions you got it. So this you have to write it and show it to me. But I am not ending today's class here. Just a question, it came to my mind, and that I am sharing with you. So you will solve it this one.